Hello everyone, my name is Marco Perez and today I am gonna present to you my topic of this International Material Research Congress 2024. I am a chemical engineering student from Mexico City and my topic is entitled Rheological Characterization of Copolymer Polystyrene-Co-Acrylonitrile Solutions Reinforced with Carbon Nanotube Sponges. As a part of the introduction, I would like to talk about the carbon nanotube sponges, what are, also about the copolymer polystyrene-co-acrylonitrile and the G prime and G double prime properties, rheological properties for rheological characterization. First of all, carbon nanotube sponges are three-dimensional structures formed principally by two elements. The first element is, of course, carbon, and the second element is iron or boron. Carbon nanotube sponges are cylinders of carbon nanotubes actually branched together using the second element, the iron or the boron, as a nucleation point to the formation of these branched cylinders. Carbon nanotube sponges possess interesting properties in terms of mechanical behavior because they have a super high strength to weight ratio and also are pretty good conductors in terms of thermal energy and electrical energy. And some of these properties can be transmitted when merged to another material. In this case, in this work, we use carbon nanotube sponges as a reinforcement phase for the polystyrene coacrylonitrile copolymer. And copolymer polystyrene coacrylonitrile is a copolymer usually used as in the kitchen industry as kitchenware for food preservation. This is due to the low permeability of the copolymer because no, caused by the concentration of the acrylonitrile monomer. Polystyrene coacrylonitrile in this work is going to be reinforced again with the help of the carbon nanotube sponges. Finally, G prime and G double prime, also known as storage modulus and loss modulus. These are rheological properties that can describe the behavior of a viscoelastic material. For the case of the storage modulus, it can describe the solid-like behavior of the viscoelastic material, and G double prime or loss modulus can describe the fluid-like behavior of this material. In this diagram, there is also a third magnitude. As you can see, G star. G star is also known as complex modulus, and the complex modulus is the mathematical tangent between G double prime and G prime, but is also related to another property which is known as complex viscosity, which of course is related to the magnitude of those two and to the viscosity itself of the material. For the methodology, we have principally two steps. The first one is the sonication of the two component mixture. First, there was a mixture between carbon nanotube sponges and dimethylformamide, or also known as DMF, but the carbon nanotube sponges were pulverized, and this sonication occurred for 2 hours at 500,000 joules of energy. After the sonication, the 2 hour sonication, we had the second step, which is a 24-hour stirring at 60 degrees Celsius. But this stirring also was with the copolymer added, also pulverized. In this work, we used different concentration of the copolymer in terms of the monomer concentration and different concentrations of the carbon nanotube sponges. For the concentrations of the copolymer, we used four variations. The first variation is 0% styrene and 100% acrylonitrile. The second concentration was 20% styrene and 80% acrylonitrile. The third concentration was 40% and 60%, and the last concentration was 50 to 50%, all of them in weight percent of the monomers. And for the concentration of the carbon nanotube sponges, there was three variations. The first one was 0.3 weight percent, the second one was 0.3, and the last one 0.5 weight percent also. For the analysis of, as a last step of the methodology, there was a G prime to G double prime characterization in terms of the temperature from 30 to 130 degrees Celsius, as you can see in this graph. And the result, of course, is a G prime and G double prime to temperature plot, again from 30 to 130 C. As we can see in the three graphs, there is a pretty constant behavior in terms of the behavior in general. As we can see, there are two lines. The first line, that is represented as triangles, represents the value of the G double prime, and the line formed by squares is the G prime. As we can see in all of the three cases, the storage modulus is lower than the loss modulus. This behavior is constant for the three graphs until there is a rise of both moduli that led to an inversion of the behavior. And I said an inversion because now the value of the G prime is higher than the value of the G double prime. In the three cases, it's the same. The difference, of course, of these three plots is the concentration of the carbon nanotube sponges. In the orange one is 0.1 weight%, in the blue one is 0.3 weight%, and in the pink one is 0.5 weight%. And we can see that the variation in which the rise of both moduli occurred in the first plot is from 125 to 135 C. In the second one, 117 to 227 degrees Celsius, and in the third one, 116 to 127 degrees Celsius. This change in behavior is related to the glass transition temperature of the copolymer. But the thing is that the normal glass transition temperature of the copolymer at this concentration of monomers is around 100 degrees Celsius. But with the addition of the carbon nanotube sponges, this temperature modified, rising up to 125, to 117, and to 116 in all of the three cases. This variation is due to the presence, of course, of the carbon nanotube sponges. Another interesting aspect about these three graphs is that there is a common point in which the both moduli have the same value. As you can see, here is around 120, again here is 120, and again here is around 120 degrees Celsius, no matter the concentration of the sponges. And that led to our conclusions. First of all, the carbon nanotube sponges modify the glass transition temperature, and in this case, 0.1 weight% led to the higher 125 C, led to the higher value at which the temperature, the range of the temperature, the glass transition temperature range started. Another conclusion is that the higher the concentration of the carbon nanotube sponges, the higher of the final value of G prime. As we can see, in the three cases, again, G prime is higher after the touch point, but the value is higher when the concentration of the carbon nanotube sponges is higher. And as a final point of the conclusions, as I mentioned, the value at which both moduli have the same value, also known as the yield point, is at 120 degrees Celsius, no matter the concentration of the carbon nanotube sponges. And that is all for me. I want to thank the Laboratorio de Investigación en Polímeros y Nanomateriales, Jean-Pierre Roulier, and the Centro de Nanociencias y Micro y Nanotecnologías del Instituto Politécnico Nacional for the given support to present this work in this international congress. Thanks for watching.